Good morning. So the last time I saw you, we were talking about the tangent ratio, and we talked about, to start with, the different sides of a right triangle. We said Miss Benton will always give you an angle, and then across from that angle is called the opposite side. Next to that angle is called the adjacent side, and the hypotenuse is always the hypotenuse of that right triangle. We also talked about, you might remember, that all this is relative, like it changes depending on what angle you're talking about. So if I change my angle now, I'm talking about angle B instead of angle A now across from angle B. This is now the opposite side, and this is now the next to the adjacent side. So just keep that in mind, that it's all what we call relative. It's all with respect to whichever angle you're talking about. The opposite and adjacent sides change. The hypotenuse, though, always stays the hypotenuse. And then we talked about the tangent ratio, the trigonometric ratio tangent. And we said tan of the angle A, the abbreviation, tangent of an angle A is equal to the opposite side of that triangle, whatever that length is, divided by the adjacent side length, whatever that is. And then we measured some triangles, and you guys figured out that these triangles would of course be proportional because they're similar by angle, angle, squiggle. We all had different little colored triangles, but we all had triangles that had the same angle degrees here, and they also had 90 degrees, so we know that that's two angles that are the same. So by angle, angle, similarity, angle, angle, squiggle, we know that those triangles would be similar, thus they would be proportional. They're matchy-matchy sides, those ratios would reduce to be the same amount. However, today we're going to take it one step further. We're not just looking at any matchy-matchy sides, we're specifically looking at the ratio of opposite to adjacent. So here I've just kind of made up some numbers. I said 4 is to 1 as 8 is to 2. And remember, last unit we did all kinds of different ratios, different sets of numbers that we wrote as fractions, comparisons one to another. Specifically, we care about the ratio, the comparison of the opposite side to the adjacent side. But what we know on similar triangles such as these, that the opposite to adjacent, 4 to 1 on the yellow ones, will be the same as opposite to adjacent, 8 to 2 on the bigger triangle, because these triangles are similar, because they're proportional. And so our next investigation is a investigation in GeoGebra. And so what I want us to do is take a look at the picture here and see what's even going on. We have this nice right triangle here, and then we have an opposite, adjacent, and hypotenuse side. So if you would just pause the video real quick and label in these three blanks what's opposite, what's adjacent, what's hypotenuse. Okay, so hopefully now you have labeled the hypotenuse, opposite, and adjacent sides. The other things we want to draw your attention to is there are three ratios down here at the bottom. We're going to specifically focus on this first one because, as you might notice, that is BC, which is the opposite side, over AB, which is the adjacent side, and that's the one we care about today. The tangent ratio is what that is. All right, so we're going to finish up this video, and in the next video we'll look at that GeoGebra investigation.